based around chords. So we've talked about tangent lines. We've done some other things within circles as well. We talked about the central angle. We've talked about the arcs, all those different types of things. The next conversation then becomes what we call chords. So plan for today, we're going to go over some definitions. I also then have guided notes for you that I'll hand out here in a minute today. Instead of having you draw all of them today, you'll have to draw this first part just to get these into your notes. But when we start doing the problems today, I'm going to hand out the guided notes so you can just do the problems right on that sheet of paper so we don't have to spend 45 seconds each time having you draw them. But whole goal today is going to be able to find lengths of segments that are lengths of chords that are within a circle. So we need to know what a chord is. So a chord is a segment whose endpoints are on the circle. So if we have this circle, I didn't name this circle, but we'll call this circle E. A and B, A to B, that's a chord. It's a chord because it has endpoints on the circle itself. CD is a chord as well, again, because it has endpoints on the circle. And as long as the two endpoints are on the circle, it's considered to be a chord. I could draw a diameter in here. A diameter goes through the center of our circle. I think you guys all know that. We've talked about it. But it has endpoints on the circle as well. So a diameter is actually considered to be a chord. And it's a chord as long as endpoints are on that circle. Now, there are a bunch of different theorems that go along with chords. There's lots of them. You don't really need to write these down because we're not going to do too much with these, especially today. So don't write this down, but just kind of some basic information. If these two chords are congruent to each other, you'll notice that the chords create arcs. There's an eraser. I've got that down. You'll notice that this chord creates this arc, and this chord creates this arc right here. If these two chords are congruent to each other, then these two arcs are congruent to each other. Again, it's not something we're going to deal with too much today. Just some information about chords. That's a little bit interesting, but again, not anything we're going to worry about today. The main one we're going to worry about, and the main what we call theorem that we're going to worry about, is we're going to worry about what if a diameter is perpendicular to a chord. So in this drawing, I have a diameter. We'll call the diameter, we'll call the diameter AB. We'll call our chord CD, and again, circle E. If the diameter is perpendicular to the chord, meaning that AB forms a right angle with our chord CD, then it bisects the chord. Bisect essentially means it breaks it into two congruent parts. So I'm going to put a label on that one as well. We'll call that point of intersection, we'll call that F. So what this says essentially, it says is that the distance from C to F is congruent to the distance from F to D. Those two segments are equal to each other. Okay. Their measures are equal, they're congruent to each other. Okay. So if again, we've talked about this a lot and we've talked about congruency. If I've told you that this is 8, then this has to be 8. But this only happens if you have a diameter that's perpendicular to a chord. Or if you see that it's perpendicular, it might be just a radius. If you kind of think about these things a little bit, A radius is really just half of a diameter, so it works with a radius too, and all of those different pieces as well. So in our first example, which is obviously looks like more like an egg than a circle, I just put a radius in there in this one. I can take the radius and I could extend the radius. Well, now it's a diameter. Okay? It's kind of the same thing. Okay? It's perpendicular to a chord. So because it's perpendicular to a chord, that means that these two pieces are congruent to each other. If those two pieces are congruent to each other, then 3x has to equal 15. Divide both sides by 3. You get a solution that x is equal to 5. Okay? That's really the theorem that we're going to deal with today. That theorem in itself, really pretty simple to understand. As long as it's perpendicular, it breaks the chord into two congruent pieces. Now, a couple things you got to keep in mind as we're looking at these today. A couple things you have to keep in mind as we're looking at these today. And we're going to get the problems here in a second. We can draw a radii anywhere. So I could draw a radius right there. If I drew that radius and I said that the radius of this circle was 10, okay, I've shown that we've got a radius that's perpendicular to a chord, so I know that these two pieces are equal to each other. They have to be equal to each other. They have to be congruent to each other. And since I've drawn this radius of 10 in here, or this radius of 10 is given to you, I could draw a radius anywhere on this figure, and we know its length. So I could take and I could draw a radius right here. Okay, I drew this one in right here. And that distance, the length of that has to be 10. I could draw another radius in right there, and I know the length of that has to be 10. What type of triangle do you see in there now? What type of triangle is that? It's a right triangle, right? What theorem do we use a lot with right triangles? Pythagorean theorem. We're going to use a Pythagorean theorem quite a bit today, using those radius and this fact that this is a 90-degree angle. Okay, so now the rest of it. I've got a worksheet, not a worksheet. This is guided notes. So you're just going to use this for note-taking purposes. This is not an assignment by any stretch of the imagination. It's just the examples that we're going to do together here in class. It's a lot easier to do it this way than to have you draw all of these every time. So we're going to try it this way. All right, so let's look at the first one. Some of these are pretty quick. So if you take a look at this first one, directions, all of this, say find the length of the segment, round your answer to the nearest tenth if necessary. So if we look at this first one, we've got a perpendicular line to a chord that's a radius. So what's the x equal to? 11. This one's pretty straightforward. X is just going to equal 11. Pretty straightforward. Okay? They have to be congruent to each other. Question number 2. Whole lot more complicated. This is what you have to keep in mind when you start thinking about radii, and that's why I mentioned what I talked about just 2 seconds ago. Keeping in mind what are radii. Okay, so we have to find this distance right here. This is what we have to find. I know this part of it is 9.3. But what I also recognize that this whole thing right here, it's a radius. So if I can find the radius of this and then subtract 9.3 from that radius, because I already have 9.3 of it, I can find the value of x. Well, they give me the diameter. Tells me that the diameter is 31.4. How do you find the radius given the diameter? Divide by 2. So my first step with this is I'm going to take 31.4 and I'm going to divide that by 2. Now, just a little warning for calculators. I had 7 last week. I'm down to 4. I don't have any more. So once my calculators are gone, I don't have one. I'm not going out and buying anymore. Hey, I've already spent that money on those. School didn't. So if I take 31.4 divided by 2, so in other words, if you use my calculators, please give them back. Other people need them too. 15.7. So this is 15.7. But now keep in mind that our radius is 15.7. So this whole distance right here is 15.7. I know 9.3 of it. So I got to go 15.7 minus 9.3. And we get 6.4. So the value for x here is 6.4. Kind of the moral of the story today is going to be you got to think about these. Okay, you can do all of them. There's not one of these that you can't do. But you're not going to just be able to say it's 11. You're going to have to think it through just a little bit as you're doing the problems today. Okay? So in this one, question number 3, again, I'm looking to what I have to find. I have to find the diameter. So I have to find this. So if I can find a radius and multiply that by 2, I'm good to go. Well, I know this distance is 4.9. I know this distance is 5.6. That whole thing makes a radius. Okay, so I can find the radius. Radius is going to be 5.6 plus 4.9. 10.5. So that's 10.5. But now that's just a radius. So our radius is equal to 10.5. Radius times 2 equals our diameter, which is our x value. So 2 times 10.5 is 21. I think that's our value for x. Again, things we can do. We just have to take some time today to think through what we can do. Just don't start. Make a plan. Question number 4. All right, I look at it. I've got a diameter perpendicular to a chord, so I've got my 90-degree angle. X is the radius. So first thing I'm looking for, when I say x is the radius, first thing I'm looking for, can I easily find what the radius is? I've got this is 5.9, but I don't know what this is. Okay, so I can't just add this and this together. I got it. I know this distance is 7. This distance is 7. This is 5.9. I don't know that one. So I have a right triangle. So this right here is a right triangle. So if I solve the Pythagorean theorem, I can find the x value. Remember the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. So 5.9 squared plus 7 squared has to equal c squared. 5.9 squared plus 7 squared, I hate this calculator, 83.81. Is So that's 83.81. That's equal to my c squared. Now I take the square root of 83.1. Clear, clear, clear. Square root of 83.81 is 9.2. That's my radius. That's what they asked us for. We're good to go. But again, taking my time in these first 4 questions and making sure that I understand what they're asking. Okay, let's look at number 10. Number 5. Okay, so again, what I'm thinking, I've got this x value right here. That's what I have to find. It's just this little piece. I know my radius is 11.3. I don't need anything down there. I know this is 10.3. So I've got my 90-degree angle. So if that's 10.3, that has to be 10.3. Now if you notice, we have our right triangle right here. If I can find that value is a leg. So we're going to go x squared plus 11.3 squared. That's not right. Why did I know that was wrong? What was I about to put? I was about to put 10.3 squared. How did I know I messed up? Besides, I looked at it again. If I didn't look at the picture, how would I know this is wrong? The hypotenuse isn't, the c squared isn't the biggest side. Okay, remember this part right here has to be your longest side, and it clearly wasn't our longest side, so that's how I know I messed up. Messing up is okay as long as you catch it. Even if you don't catch it, it's okay, I guess. So 10.3 squared. So x squared plus 106.9 equals 11.3 squared, 127.69. Solve the equation, subtract 106.09. Everybody see what I'm doing? Solving the equation. I can move it over. So that's x squared equals 21.6. I think that's right. 21.6. Take the square root of it, 4 point something. Square root of 21.6. 4.6. Again, piecing together what we know and what we can find. All right, I think it's going to get harder. Kinda. This is a big one. Yeah. Next two are really good questions. Because you got to think. Talked about this before. Math is much more fun when you have to think instead of just do. All right, so I'm looking what we have. I got to find this little piece down here. So if I can find this part right here, it's okay. So let's think about this. So if I can find this part right here, this part here and x, what do they have to add up to? 12.2, because it's a radius, right? So if I can find this part, I can subtract it from 12.2 to find my x value. Okay, well, I've got a radius that's 12.2. I can draw this. What's the length of that purple line? 12.2. The length of that purple line is 12.2. Okay, I'm just going to rename this piece right there y. Now you notice we've got a right triangle. We've got a right triangle, so we can do the Pythagorean theorem. So y squared plus 11.2 squared has to equal 12.2 squared. $11.2 squared is 125.44. $12.2 squared, 148.84. Solve the equation means I need to isolate. So I'm going to subtract 125.44. Both sides. That leaves me with 23.4. Take the square root. Somewhere over 4. Square root of 23.4 is 4.8. Is that my answer? No, that's not my answer. This right here is 4.8. That's why we kind of talked about the plan beforehand. As we said, if we could find our y value, and I took 12.2 minus that y value, 4.8, that was going to give us our x value. So 12.2 minus 4.8, 7.4 is the length of x. A lot to that problem. Make a plan. You know how to do all of the parts. You know how to do the Pythagorean theorem. You know segment addition. You know all of those things. All things that we've worked on all year long. Last one we're going to do is we're going to do question number 21. I'm just going to help you get 21 started. And then I'm going to have you find out what x is with your partner. So, we got all of this. We've got our perpendicular. This is 9.9. I can draw this line in here, right? When we think about it, we're going to really do exactly what we did last time. I know the radius. What's the radius? 21 divided by 2. 21 divided by 2 is 10.5. So I know the radius is 10.5. I have to find, and I'm going to put a y there again. If I find the value of y and subtract that from 10.5, I've got my answer. See if you can find the value of x. Work with the person beside you. Don't move by yourself. It's more fun together. And you can talk. All right, let's take a look. So Pythagorean theorem, y squared plus 9.9 squared equals 10.5 squared. Questions with that part? 9.9 squared is 98 point what? 9.9 squared is 98.01. 10.5 squared? $110.25. Okay. Now we're going to subtract 98 from both sides, 98.01. So we're looking in the 12.24. So, oops, I forgot the squared there. Y squared equals 12.24. Square root of 12.24. 3 point something. 3.5. So our y value is 3.5. How do we do with that part? So we know that's 3.5. We know the whole thing is 10.5. So 10.5 minus 3.5 is 7. Is that right? 7. Okay. So the whole thing today, what you're going to have to do today as you're looking at the different problems that you have for the day, you're going to have to find the lengths of the sides, round to the nearest tenth if necessary. Keeping in mind, of course, as we kind of started out here with kind of the big one, if the diameter is perpendicular chord, then it bisects that chord and creates that right angle. Okay? Any questions?